You ever get the feeling that the cloud is a little too cloudy? I mean, we're in the middle of a revolution right now in the way that data centers and everything work. Moving from the traditional approach, which I come from, where I'm like, that's my server. I can touch it. Oh, look, there's my firewall, and I see the cable running from my firewall to the switch to the server. And when you move that into AWS, it's kind of like, well, it's there. There's a server somewhere with a firewall there too. It's cloudy. Well, elastic IP addresses help add a little tangibility to that, to where I know and I can say that instance has this IP address, and I know that that's never going to change. It's assigned because maybe I have IP phones that register that IP address, or VPNs that point, whatever. Fill in your situation. That's elastic IPs. We're going to talk about that. Then we'll talk about, I would say, one of the most amazing pieces of AWS, which is elastic load balancers. And I say it's amazing not just because I think everything's amazing with AWS. I say it's amazing because traditionally load balancers are a big deal. I mean, you're going to Foundry networks, buying big old appliances. I mean, that's a big deal. There's training, there's weeks, and just the way Amazon has rolled this off and the power that you have by using ELB is going to blow you away. So I'd like to just dive right in. I'm taking you over here to the EC2 management console. And these are just some instances we spun up to play around with. And every time you spin up an instance, you're going to get this, which is the DNS name to be able to access that, which is handy because you can not only access it, but look at it and say, okay, well, that's what my IP address is right now, 204.236.181.209. If I scroll down, it lists it right here as well. But will it stay that way? Maybe. If I keep the instance running, if I shut it down, it's probably going to change to something else. And if I'm relying on knowing what that is, I need to know what that public IP is for whatever the use is, then I want it to stay the same. Like I look right here, as a network guy, I'm looking at this, I'm like, oh, that's meaty. I like that. I look at that IP address, I'm like, that feels good to me. I want the same thing for the public IP. So shoot over here to the left-hand side, elastic IPs. Now, the elastic IPs are so, the reason I didn't need a side is so simple. You just say, okay, I want to allocate a new address. Saying, are you using EC2 or the Virtual Private Cloud, VPC? I'll say, well, I'm in EC2 land right now. Give me one. And bam, I've got one right there. Now, that's it. I now have a public IP address that I am able to associate with whatever instance that I want. Now, the neat thing about this is not charged. I mean, from Amazon's perspective, you're using a public IP address no matter what. So why not? Why not let you pick one instead of using their default one. Sorry, my brain just checked out for a second there, but I'm back. But why not let you choose what it is? Now, there is a charge associated if you camp out on these. Amazon will start charging you per hour where you are having a non-attached IP address. Now, it's not going to be an absorbent amount, but it'll come out to about $5 a month or so. So if I just, if I start stockpiling these things, I'm like, okay, I want a little stockpile here that I can use, so I know what IP addresses you can. You can do that, but just think $5 a month, $5 a month, $5 a month. That's what you're doing. Now, as soon as you associate it with something, like if I were to go here and say, okay, that's the IP address that I want associated with that Linux instance I was just looking at. As soon as I do that, now it's blended into the solution. It's blended into the, hey, you're paying for that instance, so the elastic IP address is just included. Now, there's some extremely nominal charge if you just keep doing this. If I go in here and just say, okay, I want to associate this, I want it going over here, yes, associate. Let me deassociate. I mean, it's something like, and I don't know, and then these numbers change all the time, so please don't quote me, but it's like if you disassociate and reassociate these things like 100 times or something like 100 times a month, you're going to end up paying like 10 cents. So it's not like, wow, it's just FYI. So these are now associated. So now I know any single time I access that IP address, I'm always going to go there, and it's always going to be that way as long as that instance is running. That's the beauty of elastic IP addresses, is I have control and I can assign them, only charged if I disassociate and don't use them. So elastic IP is pretty straightforward. Let me get into where the true power lies, and that is in the elastic load balancer. Now I want to show you traditionally what this is if you're building a traditional data center, and then we'll talk about how Amazon does this. Normally you've got, we'll say, the internet out here. So here's the internet, and you've got everybody coming into your firewall. And you'll go out and buy, and I'll draw it here logically. You'll go out and buy a load balancer. Now, I will say Foundry has made a name for themselves. They make really good load balancers. I've seen those a lot in the industry. So you go out and buy a pair. Usually you want some redundancy. So a little pair of redundant Foundry load balancer. And then that comes into a switch. And you've got your different servers, aka instances in the AWS world. And what you'll do is you'll say, okay, here's my public IP address. Let's just say that's 180.1.1.1. That's coming in here. That's what people go to www.cbtnuggets.com. It translates to that, and then that ends up at my firewall. And so the firewall now takes that and translates that to the private IP address of the Foundry. We'll just say it's 10.1.1.1. Then the Foundry, when it sees the request, starts load balancing. It says, okay, the first request goes to you, then it's going to you, then it's going to you. Good. And then flip around, going to you. So you're stretching the load between multiple servers. And as a bonus, you probably have some kind of keep alive set up to where this guy's sending a ping or whatever every 30 seconds or 5 seconds or whatever your interval is to make sure these guys are all healthy and they check out. And if one goes down, he's removed from the load balance group, and the other two pick up the slack. So that's the traditional approach for load balancing. Let's look at how AWS does it. All I need to do is come in here and click on load balancers. And nothing's here so far, so I'll click on create. It's inside of EC2. Name, I'll say this is IIS web traffic. Maybe it's coming to my group of IIS servers we created before. So now Amazon, thinking ahead, is like, okay, I bet you 90% of the world is just going to want web load balancing. So we're going to put that in here. That's what this load balancer is going to do by default. And you can remove that if you want, but we're figuring that's probably what you want. Now just let's talk about what this means. What this means is when the load balancer gets a request on port 80, it's going to send it into your instances on port 80. Do I have to do it that way? No. I mean, maybe for some weird circumstance, I want to receive on 80 on the outside, and maybe on the inside, I'm using some kind of whacked out proxy, so I'm sending it to 8080. I can do that. The load balancer will distribute those as it comes in. So that is a possibility. And let me just put my original back in. But for now, let's just do the basic. Let's just say HTTP. So I click on next. It says, okay, I got that. Now, how do you want me to make sure that your servers are alive in this process? So they're saying, okay, what's your ping protocol? Now, normally when you ping something, I mean, this is a ping. You come to a command prompt and you say ping 4.2.2.2. Now, what that does is that sends an ICMP echo message. So I'm saying, okay, boom. That's our little sonar echo. Echo, are you alive? And that server comes back and says, ping, echo reply, I'm alive. Now, ping is great to find out if the server is alive. But what about the stuff on the server? What if, for instance, the server is running, but IIS, again, Microsoft finds a bug, not that that would ever happen, but IIS, the web server, crashes. It's no longer working, but the server's up. Well, our echoes don't do us any good because the server's saying, yeah, I'm fine, but IIS has frozen. It's crashed. So when it says the ping protocol, I'm going to say, well, yeah, I want it to use HTTP. And I'll tell you what, I want you to go get a web page for my server on port 80. I want you to go get index.html or index.html, whatever you have as your web pages on your server. This load balance every, you've got your health checks, amount of time between health checks, 0.1 minutes to 5 minutes. So we'll just say 0.1 minutes is going to go out there and make sure that server is still serving up that web page. Now, you can see down here we've got unhealthy and healthy thresholds. This means how long until I consider you unhealthy enough to remove. So right here we can see an unhealthy threshold of 2. So once we've hit 2.1-minute intervals to where it's not serving up this web page, you don't. A lot of times you don't just want to yank somebody because they missed one. It could have been he's just busy at that time. There could have been a lot of reasons why he missed that. So we'll say once you miss 2 of them, 2 health checks, you're out. You're out of the group. And before I return you to service, I want to get you successful on 10 health checks every 0.1 minutes. Does that make sense? So the server misses 2, he's out of the game, sitting on the bench. Meanwhile, you've got the doctor going, okay, you okay, you okay, you okay. 10 times later, he's like, okay, I think he's good, back in the game, and throws the web server back in to see if he's able to stand up to it. So those all go together. Also, response timeout says, I'm going to wait, when I say I want your index.htm, I'm going to wait up to 5 seconds to receive a reply, and you can adjust that, but to receive a reply, and if I don't get a reply, that's bing, 1 against the unhealthy threshold. Now, one of the most common questions that I get when going through this page is, well, can I go lower? Like, I'm looking at these ranges saying, okay, time between health checks, 0.1 minutes. Can I get if you're thinking a lot of people, they're like, I want like a 100 millisecond timer to where it's just going, hello, doing these little ping options, request as fast as it possibly can to make sure that server is responding. Well, think of it from, number one, a server perspective, but also Amazon's perspective. They've got these load balancers that are scaling for hundreds, if not more, thousands of potential clients. If all these clients are saying, okay, I want a 100 millisecond timer, the load balancer would explode. It just doesn't scale that. And same thing with your instances. Your instances are constantly like, here's a page, here's a page, here's a page, here's a page. It's trying to generate pages way too fast. So Amazon puts it into a good normal range of what people would use. And if your web system, if you're trying to use 50 micro instances of servers, that's one thing. To where it's like, okay, that server's crashing, you got to scale your instances to something reasonable rather than having a billion micro instances that just can't keep up with the amount of load that you're throwing at it. So that's why they set the values that you do. So now I continue and saying, okay, we've got the health check configured. Let's now add the instances to the load balancer. So I'm going to say every single one of these is going to receive those web requests. I'm going to click on continue. So it's just saying, okay, here is your final word, if you will. This is the final summary screen of what we're going to be doing. Web traffic, we're trying to access this web page on each one. Here's our timeout, here's our interval, here's the instances. So it's the summary, and I click on create. So now it says load balancer has been created. Here we go. So I click on this and I can see the description. This is, and I'll talk a little bit about this in a second. I see all of these instances, which notice their status: out of service, out of service, out of service. Well, okay. I gave it away. It says, first off, instance registration is still in process. It's creating the load balancing instance, but I'll tell you what, it's going to stay out of service. And let me ask you, why? Well, because none of these instances are configured as web servers that have the page index.html. So it's going to start trying to access these guys, and it's going to say, oh, well, sorry, they're down. They're no longer in service. This system as a whole is down as well. So you can see that I can come in here later on and I can remove certain instances. I can click the plus minus and add other instances. So it's not like security groups where once something is in a security group, it's doomed and to be there forever. Description. Here's the big thing. When you create a load balancer, and first off, it's not free. Let me mention that. I brought up the webpage for ELB pricing. It's definitely nominal, but something to consider. So, for instance, if I'm in Virginia, it's costing me essentially 2.5 cents an hour that I'm running this ELB, and there's a 0.8 cents. That's not 8 cents. That's 0.8 cents per gigabyte of data processed by the load balancer. So again, it's, as all pricing in AWS is, it's very reasonable if you really think about it. You're like, okay, I can see there's going to be some charge for using this, but compared to going out and dropping $10,000+ on some Foundry load balancer, it's reasonable to do something like that. So it is per zone. So as I click between the zones, you can see that I gain price or lose price depending on what zone I am putting those in. But when I create this is where I was going, it automatically creates DNS records for this. And that's because Amazon is the one managing the public IP addresses going to this load balancer. It could change behind the scenes, and Amazon will update that A record for you. So, what your strategy is, and actually they give you the strategy right below. Never create an A record to a specific, don't ping this guy and find out what its IP address is, and then create an A record to that because it'll change. Instead, create a CNAME record. And this is if you ever, you can use Amazon Route 53 as a DNS provider, or I think for some reason the name OpenDNS comes to my mind, but I know that's not it. There's all kinds of DNS providers on the internet. Your wherever you register your domain name likely will be able to create DNS records for you. So you create a CNAME that says, okay, my CNAME is. Bring Notepad over. My CNAME is www.cbtnuggets.com, CNAME record, and that points to, that's where you'll come over here, and you'll be doing this in your DNS control panel. That points to that. And that all the CNAME is a DNS record that points to another DNS record. So now, you don't tell your customers, hey, you want to go to IIS-Web-Traffic-81, you just say, hey, go to cbtnuggets.com. That points to our load balancer, which then goes out and checks the instances to make sure that these instances have the service, checks the instances, make sure that the service is running and life is good. So that's the idea of handling a load balancer. So think of that as the core functionality of the load balancer. Now let's get into some of the features. Now we're right here on the main description page. I want to draw your attention down to this port configuration. It shows the ports, of course, of what we're forwarding in there, but notice we've got this feature called stickiness. What stickiness does is allow you to home somebody to a specific server. So, for example, let's say, and this is primarily how you've handled your web servers, how you've developed them to the way that respond to the clients. Let's say we've got a user sitting out here. A happy user comes into our system and he gets load balanced to this middle server. Now, based on the way that you handle things, the next request that comes in might end up putting him on that server and that server. And if your web application isn't designed to handle that, his session starts breaking, broken links, all that kind of stuff. It's like, wait a sec, you're saying you've got a maintained session and you're getting sent to all these different web servers. Again, it would be more of your web designers behind the scenes and how they handle it, but maybe you can't have that. At that point, the stickiness feature allows you to go in and say, okay, when this happy user comes in to use my system, the very first time he hits the server, the AWS load balancer is going to store a cookie. I'll just put CK, a cookie on his system that's checked every single time he comes back. So when it says you're going to this middle server, from there on out, he's going to go to that middle server for all future requests. Now, it has an expiration. Let me go back here. You can see by default it's disabled, but if I choose enable the load balancer generated cookie, I can put in a number of seconds. So I can say 3,600 seconds and that cookie expired. Or I can say, well, I want to leave it blank and that way that user always goes to that server. I would not suggest using that, because you're kind of defeating the purpose of load balancing. I guess you're still getting some, but it's not really dynamic. It's like, okay, you came in and now forevermore you will go to that server. So that's how that works. Now, when you get into the application development side of it, you can find out that we can create cookies that go to certain application instances, but we're not going to dive into that right now. Just for now, as the main feature, the load balancer will generate the cookies for us. So we've got the stickiness. Now we've got the instances. We saw this. We can also, I mentioned add or remove servers to this cluster. We can also say, I've got another cluster of instances over at this availability zone, so we can add instances in from over there. So think of this load balancer. It's kind of like, here's Amazon region, and you've got all these availability zones inside of here. Load balancer kind of sits right here and can distribute to servers within one availability zone or another or both. So that's pretty powerful if you think about where that load balancer sits. We've got the health check, which this is where we can go in and edit our settings on that if we want to change it. We've got the security. If you want to be able to manage the security group assigned to your load balancer, that's where you would use VPC, Virtual Private Cloud. Again, coming up, will be one of the things that we talk about. Otherwise, Amazon creates and manages the security group for you. And the way it knows what to permit is what you configure right here. So essentially, anytime you configure a port, it's going to say, I'm going to allow everybody to access that port to do my load balancing. So that it kind of is an all-in-one security group. You won't be able to go, for instance, I can't come over here to security groups and say, oh, okay, where is that guy? He doesn't exist here in this list. It's all Amazon managed. So going back here, let's talk about some different listeners. HTTP is really easy and really common that you can set up. But if you hit this drop down, you notice that you have a few other options. Before I hit HTTPS, let me jump straight to TCP. TCP is your generic listener. This means any TCP-based application can be defined here. So I can say, I have a cluster of World of Warcraft servers that they all run on port 7776 or I don't know, whatever port it is, and I'm gonna send that through as 7776, and then start this is for the same instances. So when I hit save, it's now going to take all of those ports. It's modified the security group, and all those ports are going to load balance between these three servers. So I can define whatever custom service I would like to do. Now, let me talk about HTTPS. This one is very powerful. One of the big things that adds load to your server is doing encryption, and a lot of it. So if you're running some kind of secure website, let's say you are an online bank. We'll just say a bank right here. People come in and they're going to expect an HTTPS, an SSL session with you so that all their data is encrypted going over the internet. Well, when you get 10, 100, 1,000 users on your web server where your web server is having to encrypt and decrypt, and I mean, you remember the key pairs, right? That's the same thing that the web security uses, to where it's going to generate key pairs for public-private key cryptography, generate a session key. I mean, there's just a lot of overhead associated with that. That's one of the things that can choke your web server, is handling a bunch of SSL sessions. So here it is. Here's what Amazon did. They enabled their load balancer to be the HTTPS termination point. Meaning, this area right here, I know this is still all Foundry, blah, 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 but this area behind that load balancer is all considered trusted space. Remember, Amazon is going through all the trouble of being PCI compliant and making sure that their networks are secure and stuff isn't getting to the places that it doesn't belong. So it's a trusted zone. It's a safe zone. So what they can do with the load balancer is terminate HTTPS right here, meaning the user gets encryption where it matters over the public internet, terminates right there at the, let me get the Foundry out of there. This is ELB. And then from there, passes it to your web server using HTTP. Oh. Okay, pause for a moment, take a deep breath, and go, oh, that is cool. Here's why. Number one, it gives you one place for your security certificates. One of the painful things when you go HTTPS, when you go SSL, is managing all your certificates, making sure they're up to date. You have to renew them every X number of years, depending on what you've bought. Every server has to have the same certificate and be responding for that website. It's a pain to manage those certificates. Now you've got one place to install that certificate, and it's going to be handled right there. Second thing that it does is terminate all of the heavy processing right there on the load balancer. So it's the one handling all the encryption and decryption of the traffic. Okay, if you didn't pause before because you didn't get it, pause now and go, oh, because that saves you all of the pain on these instances where normally you would be able to run your web services, we'll say off of a small instance, but because of all the SSL that you're handling, you've got to jet that up and maybe go for a medium or a large instance that's able to handle all of the encryption, decryption. Instead, you've got the load balancer that's doing it all for you. That's amazing. So, and I'll tell you just from experience, dealing with HTTP is so much easier than dealing with SSL or HTTPS. So coming back in here, let's take a look at the options. We've got HTTPS is the load balancer protocol, so it's going to be received on 443. That's the well-known port for HTTPS. And then you can say, well, I want to drop the encryption at that point. We're then moving into that trusted zone. over here, so I want to go HTTP. Or you can also choose if you want to keep it HTTPS and pass it right through to the other side. Now, there's actually a big difference of what I just did there. If you do this right here, the ELB is still decrypting the packet. Good grief, this is getting messy. Hang on. There we go. So if I put HTTPS to HTTPS, what that does is terminate the HTTPS right here, decrypt it, and then re-encrypt it as it's going to the server. You might say, well, that seems like a waste. Well, not really, because once you do that, if it kept it encrypted, the ELB wouldn't be able to see what's going on. So by doing it this way, you still can have, for instance, like sticky sessions. The load balancer wouldn't be able to see the cookie of that happy computer out here if it was just passing through everything encrypted. So by having one encrypted session end here and then start another one, it can actually examine that traffic to say, okay, are you using sticky sessions? Okay, if so, I'm going to keep going to that same server. Whereas without that, you lose the ability to do sticky sessions. Now, what if you're thinking, okay, I don't care. I do not want this point of decryption, whether it be I don't feel secure with that or whatever. How do I get it to just pass it through HTTPS all the way? Well, in that case, what you would want to do is add a port, but you would make it a TCP and just say pass it from 443 to 443 on the other side. And at that point, the load balancer doesn't even look at it. It's like, okay, you are 443 traffic. You go here, you go here, you go here, you go here, and it uses a round robin to go between all the different servers. So that would be an inspectionless flavor of HTTP. But you do also have some options. I'm going to mention these. This is the cipher. By default, these are the ciphers that Amazon chooses. And when I say cipher, this is what kind of encryption, what kind of hashing are you using. Without diving too deep, you get to choose if you want to use certain kinds of encryption and not other. By default, it uses AES 128 and 256-bit encryption, which is great. That's pretty much the de facto standard nowadays, as well as down here using MD5 or SHA-1 hashing, depending on what the server and what the client dictate they are able to use. So most of the time you're going to say, okay, that's fine, whatever. Keep it at the default unless you have a very specific reason, but for choosing certain ciphers. But this is also where you can add your SSL certificate. So if you have gone out and got a certificate, meaning anytime you create a secure web server, you have to go get a registered certificate from one of the many, like VeriSign is one of them. Just about any web hosting provider can generate SSL certificates that are trusted by people's web browser. So you probably have gone to a website and it says, boo, pop-up notification, this warning, this website does not have a valid security certificate. You might have seen that. So you don't want people to see that. So you get a valid one, and you name it, you put in the private key and the public key, and you pretty much copy and paste it in there, and then hit save, and now you've got the SSL certificate stored on the load balancer, and it's able to use it. Now you'll notice that the save button is grayed out, and that just means you can't do SSL, you can't do HTTPS without having a SSL certificate in place. So let's look at the other option. If I drop down right here, SSL Secure TCP, it's almost confusing at first. You're going, okay, well, wait a sec. HTTPS, SSL, HTTPS, SSL. I get it. What's the difference? Why would I use one over the other? Well, HTTPS is more of, think of it as like a layer 7, like application layer inspection. When you use HTTPS, it's looking at the headers of what's inside of there. What web server is it going to? It's storing a cookie on there to where it can do sticky sessions and things like that. That's all part of HTTPS. When it's straight up SSL, which you could use for HTTPS, it would be fine, but you lose that functionality. It's more generic. It's more of like, okay, I'm receiving it, I'm decrypting it, and then sending it off on port 80, but I'm not looking at it at all. No looking at the headers, no looking at the cookies. I don't put cookies on the host. I'm taking normal encrypted traffic on whatever port. Maybe you have SSH traffic coming in. That's another type of SSL. It'll look at whatever port it is, decrypt it, and then send it off on whatever port you have. So, I mean, that's where it's up to you. If you have some kind of custom application, maybe it comes in on port 8000, and you want that thing encrypted over the internet, but you want to be able to pass it through on port 80 on the other side, decrypted. Perfect, but not do anything with it. You're not looking at it, not inspecting it, not putting cookies on the host. That's where the SSL piece comes in. So there is Elastic Load Balancing in all its glory. It makes me feel like the title of this nugget should have been Elastic Load Balancer and Elastic IP, with like 2-point font size for this guy, just because they're so simple. You turn them on and then you assign them to a instance and you're done from there. Elastic Load Balancing, tons of functionality, but so super valuable. And I want to make sure that I bring this back to, again, the new cloud model that we're looking at. In the new world, your instances, well, I'll say Amazon's design and original model for them are that they are disposable. To where you've got instance A, instance B, instance C. And this is exactly how Amazon has designed their business, to where they can spin up a new web server in a matter of minutes and bam, now have another workhorse handling requests. It's around Christmas time. We need to add 50 more servers to this availability zone because we're getting a ton of requests. And the load balancer can take those and fit those right into the scheme of things, to where it automatically adds those instances as they come up to the load balancing scheme. And then as they go down, the ELB says, okay, well, you are now out of it. You're shut down. You're removed from this. So you can bring those up and then shut them down, and the load balancer handles it all. That's the model that we're looking at. But with that load balancer, that's what gives you the possibility to utilize all your instances as one. I hope this has been informative for you, and I'd like to thank you for viewing.